Good evening and welcome all to the Predictive Analytics Bootcamp. And we are going to discuss and understand about what is predictive analytics and have some hands-on practice also during this bootcamp. A couple of hands-on practice with during this bootcamp. Right. So let's start. So there will be a agenda for this boot camp. The agenda will be like this. So we'll start with what is predictive analytics, uh, then types of predictive analytics we generally use, application of predictive analytics, terminology we use in predictive analytics, and hands-on practice with Python. If I start like how you define the predictive analytics, how one define the predictive analytics. So I'm asking you people, like if someone asks you that what is predictive analytics, so in a nutshell or in a very simple terms, how you will explain or define a predictive analytics. So how one define the predictive analytics part? Finding unknown things from known things. Okay, what else? Prediction of future. Okay, forecasting future. So predictive analytics is a domain where our intention is to predict using different statistical techniques, data mining. We use modeling, we use machine learning algorithms to analyze the current and historical data. So we analyze, so based upon the historical data, the information we have, and the use of machine learning algorithm and other data mining techniques, we would like to predict the future or otherwise unknown events which are going to happen this. So anywhere, if it is of interest, using the old data, existing data, historical data for the prediction of future, so that is the domain going to be predictive analytics. So is there any specific, I will say, industry, any specific domain or role where there is a use of predictive analytics? Is there any specific industry where we use predictive analytics, otherwise we don't use it? Is it domain specific? Is it industry specific predictive analytics? Is it role specific? Is it problem specific? So we will find that the use cases we will see later on. So we'll find out that predictive analytics is something which is across. We can use across the domain, across the role, right? Across the problem statements, wherever the intent is to forecast and to predict. Now there are in predictive analytics, there are few steps are involved, and depending upon author to author, depending upon this, so these can be broadly classified as 6. It may be broadly classified as 8, 10, and so on. Okay, so but there are few steps which are must have. So whichever problem you take in predictive analytics, wherever you take, okay, so one need to understand and one need to take care of these steps are there. So only it's not the modeling, it is not only the mathematical or statistical modeling which is the predictive analytics, it's the complete journey. So starts right there from defining the problem. And you do please understand, like it's not that always a data is given to you, it's not always that a CSV file is given to you, it's not always that Excel file or some information is given to you and asked simply keep predict this, okay, or predict y, or use this algorithm. No. So in real world, how the problem has been defined, the person, the user, your client comes with the problem statement, and it may be a very broad problem statement. It may be his or her pain area. It may be something they want to redo for their customer experience. This is something they want to increase the efficiency of their existing processes. Okay, so the problem statement can be a very broad, it can be in a general layman term, right? It will be It will be a paragraph. It may be a 1 or 2 pager note given to you about the scenario, about the problem statements, right? About their need, about their desire for the solution. So defining a problem from the user expectations, right, or end user expectation is the key for any analytical person. The person who want to be here in the domain, it's not only the algorithm which play the major role, it's not the Python, the programming languages play the role. The key step, you're the first step you take for taking any assignment of predictive analytics is defining the problem. So while defining, you should define the scope, you should define what type of information or data is required, or whether that information is available or not. Okay, how many man hours, man days, the resources, right, data situation, right, and what is the expected result the client is looking for. Then only we should go into collecting the data or the other step. So the most fundamental and the most common is the defining the problem, and it is generally common that many projects does not take after taking so much of efforts, generally fails, or are unsatisfactory because the client and the analytic, they have the different perspective about the same problem, or their so if so defining a problem is a key to any successful predictive analytics problem. Okay, then come the data collection. So based upon your problem, you collect the data. It's not that you have the data then you define the problem. So first define the problem, then collect the data. Data can be your internal data, can be your external data. Data can be in many forms. It can be in your relational or tabular form. It may be unstructured, right? So then the data collection will start. After you have collected the data and the required information based upon your problem definition, then a data pre-processing is required. And data pre-processing is something which is based upon the algorithms or models we are going to use, first. Second, the type of data we have in our hand. And like for example, the common data pre-processing are like dealing with the missing value, or converting the data type, looking for the appropriate data type, is about scaling the data, right, and so on. So data pre-processing is there. Then comes the most fundamental part, which is called as EDA. So what is the meaning of EDA? If someone says that it is the most fundamental part, not into predictive analytics, but most of your analytics domain. So what is the meaning of EDA? What is the meaning of EDA? So EDA is exploratory data analysis. Here, here we are just, you explore. We look for the information which is available in our data set without any hypothesis, without any baggage. We just explore the information. We draw different visualization, we look for some hypothesis testing, we do the tabular, there we create across tables, right, and we look for the summary statistics and so on. So EDA is exploratory data analysis, is a it must to be done before actually running your model, because it will provide you a lot of analysis. You people might have heard about something called as spurious regression. So yeah, you give whatever information or the data set to the algorithms, so you come out with some sort of output. Okay, but practically or as per domain, it might not be a feasible one. It is not a correct one. So, or it is spurious. So you should, in this step EDA, we actually look for the whether these variables have some sort of independent and independent relation, they have a cause and effect relation with them, what the domain people will say, and so on. So that is the key to the exploratory data analysis for your any before you take up any problem, or any before actually you doing the modeling, start modeling for with the given data, EDA. Then after the EDA has been done and we are sure about the pre-processing, we are sure about the probable cause and effect, probable relation, then we look and choose the appropriate model. right, for our problem. And these models are from the machine learning, deep learning, and the other various statistical models we can pick from. We in the modeling there are multiple steps in between also, like we train our model, we fit our model, we look for the model accuracy, we compare the models, we do the hyperparameter tuning, and so on. So modeling has further can be divided into multiple steps. Then comes the deployment. So then after this you deploy, or you give it to the client, or you deploy at the client's site, or you may deploy at the in the web or the cloud, and then start using it. So this is how the predictive analytics journey looks like. It starts from the defining the problem. It's not start with the data collection or collecting the CSV. It start with the defining the problem. Then after defining the problem, we do the data collection. Then after data collection, we do the pre-processing. Yes, before pre-processing, we don't do the EDA. So we do the pre-processing, look for missing value and so on, and then do the EDA or exploratory data analysis. Once the EDA has been done, then the modeling, which has sub parts or sub steps like model fitting or model learning, model training, and model accuracy, and model hyperparameter tuning. Then comes the in the final is the deployment or deploy model for the client or on the server or on the cloud. So that is the broad steps are there for any predictive analytics problem. There are a couple of predictive analytics types or problems are there, and to solve those problems there are some types are there. So broadly if we say that there is are you people know, like the broad umbrella is AI. So many predictive problems are the hybrid of some machine learning algorithms, some AI, and some IoT, and so on. So artificial intelligence, some predictive problems are pure algorithm based or database are there. And in the deep learning is when we are using the artificial neural network for solving our problem. So the your predictive problem can be from any of these domain or subdomain. So your problem can be of AI plus machine learning, AI plus deep learning, or mix of all three, or mix of any two, right? So this is how the predictive problems can be come into. If we speak specifically about the machine learning part, right? If we specifically speak about the machine learning part, so machine learning can be classified into three or four. So generally the broad one are the two, which is supervised and supervised, and after that we may classify it as semi-supervised and reinforced machine learning, and so on. Okay, so if machine learning is defined as supervised and unsupervised, okay, so how we define supervised? What is the difference between supervised and unsupervised machine learning problem and semi unsupervised machine learning problem? What are the difference between this? So supervised is a problem where we have understanding, or we have the available data for our label or target, and also our independent variable. So that is the domain of supervised machine learning. And unsupervised machine learning, where we only have our features, not the label or the target. So that is the unsupervised. Semi-supervised is the one where we have partial availability of our label, right? Because of any reason, we have availability of not complete data set, but maybe some percentage or partial labeling is available, and much of the data is still unlabeled. So that's come under the role of semi-supervised learning. So supervised learning is can be further classified into regression and classification, and we'll see later what are these are. There are many applications of predictive analytics, and you people have just shared on the chat also that there are uh, from different domain, from finance, from sales, from public policy, and so on. So there are very broad application of predictive analytics. So it is used the same can be used in organizations, businesses, governments, startups, right? Your public policy, to help and solve the problems, right? So it has a broad use area is there. If I talk about the specific to the industry, so you can think of retail, agriculture. A lot of prediction or new startups are coming up into this domain which use these techniques. Supply chain, a very good use of predictive analytics to for your inventory management, for your supply chain management, logistic management. Manufacturing, again, your machine maintenance, failure, manufacturing time, and so on is there. Health and insurance, there is a lot of, we have seen in COVID time also, and before that also, in predicting the diseases and so on. Sales and marketing, there is always a good use cases of predictive analytics in terms of predicting the sale, predicting the revenue, right, predicting the market share, predicting the product failure or product success, right, and so on. So sales and marketing, there is a good use cases are there, including digital marketing. Government and public sectors, we have seen that they are using the predictive analytics for a lot of problem solving in terms of oil refineries, in terms of road laying, in terms of output, inflation, GDP, right? So there is a lot of use cases in the government and public policy domain also. Bank and finance, in terms of risk mitigation, in terms of exchange rate prediction, in terms of your compliance issues, your legal, in terms of fraud detection, early fraud detection. So you will see that there is a whole use cases across the domain and across the industry for the predictive analytics. So you just need to understand that prediction and forecasting is very fundamental to plan for your future, or to the risk mitigation. If we will be able to segregate the unwanted customer, unwanted user, unwanted product or incidents versus the wanted one, it will be a good for the company and good for the organization. Similarly, if we will be able to predict future with some better accuracy, it will be good for resource deployment, manpower planning, your capex, and so on. So every domain there is a good use cases are there. Yes, Kriti. Yeah. So there are a lot of use cases. So whatever is your interest area. So if there is, like, for example, in gaming, so in a gaming industry there is a lot of predictive analytics we can use. So in terms of software and so on, so there is a lot of predictive analytics use cases are there across the domain. Now I will share with you the some in locally, not global one, use cases which will help you to broaden your perspective and the use cases of predictive analytics. Like, for example, India, there are around 4.7 million blind people are there, and 66% of them lose their eye sight due to cataract. So cataract is a major cause of people getting losing their sight or getting blind is there. So if anything, and controlling the cataract and diagnosing a cataract or early detection is not a challenge, but it is because we have a large geography. People are not that much educated or aware, especially in low income group. They just keep on avoiding, so or reach to the major public health uh, centers and so on. So that is there. So in this case, so this is a use case is there. So there is a definitely a problem there. Can we solve this problem using a predictive analytics? So this is something which is related to the people. This is related to the people who are at the bottom of our pyramid. They don't have a good access to the healthcare facilities, right? Because of income, because of reach, because of age group, etc. And these are the huge numbers are there. So can we use the predictive analytics in this? So it's not always a stock prediction, it's not always weather prediction, it's not always sales prediction. This is can be the use case for your predictive analytics. So here, like, Tamil Nadu government has come up with a simple click the picture and image recognition and the early detection for the whether the person has a cataract at what percentage and so on, so that the data can be stored and the timely healthcare services will be provided to the person and saving the person eyesight. So this is the very innovative, useful use case and practical use case of predictive analytics. Another one is our Andhra government, okay, forecasting the energy need. So Andhra Transmission Corporation, for the first time in India, they start predicting using the AI and ML. Okay, your techniques. So that was what I have shared with you. It can be one, it can be either or a mixture of AI, ML, and deep learning. So next day prediction of your electricity demand, and that too for an accuracy of 15 minutes each, right? For an interval of 50 minutes. It's not their average for a day or average 24-hour energy consumption. No, average of 15 minutes duration. So they start predicting, and how it is going to help the people at large, because the Andhra Pradesh Transmission Corporation can plan early. They can plan for the there will be less load shedding will be there, and more productivity for the people, less more productive manufacturing hours are there, or factory hours will be there. So that is again a use case. Uh, use case are the for the predictive analytics. Another use case is like, for example, advising farmers on crop diseases, right? So this is again a use case, very fundamental, very close to the people at large, especially in India, where we have so much diversity in terms of agriculture, the cropping pattern, right, and so on. So we are the also agriculture dominating country, where the percentage of people, more than 45% of people, are directly involved into the agriculture. So this is helping the farmers for the early crop disease prediction, right? So it will not only help to increase the farmer productivity or crop productivity, but it will also help to reduce the cost of input for farmer, more yield, better yield, and less utilization of pesticides and so on, means healthy environment and less pollution, or the poisoning of water, land, etc. So that is again the use case of the predictive analytics in agriculture. Then there is a something called as a breast cancer early detection. So that has been a Bangalore-based deep tech startup which has started with this, and it is helping. So instead of using for the early detection, and in India, or as per WHO, 1 in every 12 women have the risk of the disease. So that is also very using AI ML, not only in a one disease, but it can be used across the healthcare domain. It can be used for across the medical diagnostic uh, use cases. Then, so from moving from your agriculture, from your electricity, public products or public resources, so there is something like IndusInd Bank, who has used AI ML for lead management. So what is lead? What is lead management? So lead management is something where it is like if uh, you have a chance of the customer is a probable chance of buying the product or using the service. So that is called as a lead. Lead is still not if matured, convert into sales. Okay, so unmatured sales, or these are the leads. So the lead management for IndusInd Bank, right? And it's not the IndusInd Bank. There are I am sure that other banks, the companies, they are using some sort of AI ML algorithm to for the lead management. It's going to help, yes, potential customers. So it's going to help the companies, the banks, the different institutes to reduce their cost per acquisition or cost per sale, in terms lead to better productivity or better revenue for the company, or the profits for the company. And also over a period of time, we will see that the cost of the goods or cost of services go down, because now the company have a less cost of acquisition, or less cost of sale to the or maturity of lead. So that is the use case is there. So you see that in the business very front end, right? And lead management is something like every company is selling something or other, either a product or a service, B2B, B2C, B2G, or different format. So lead management is something where the predictive analytics can be used. E-commerce. So e-commerce now is growing day by day, in terms of it's not only about food, it's not only about your products, electronic goods, it's not about your fashion, right? Jewelry. So you see that there is a lot of e-commerce transactions are there, and which is in terms of tough of digital money, digital currency, in terms of physical goods, in terms of digital services, and so on. So how we to detect and control the e-commerce fraud? So if you will be able to predict and detect the uh, commerce fraud, it will be helping to reduce the losses and also providing the better service to the customer. B2G is business to government. So in terms of tender, so the government is the customer and the businesses are supplying to the customer in terms of, like, for example, defense, roads, right? And there are so many services where the government purchase from the SMEs or the industry for the consumption or for the further distribution. So we have seen that the predictive analytics use cases are across the domain. So you just have to be innovative. You just have to be look for creating some system or a solution which is very maybe so define the problem which is in around you. So as a student, as an application, so yes, we learn a lot of time from the data set or from the CSV. Focus is on the algorithm. I again and again says that the algorithm is the important part, is not, but not the major part, right? Major is like how you going to apply your domain knowledge. So if as a student, if as a learner, you people also look for some small problem in and around you, maybe in your college, maybe in your canteen, maybe in your hostel, right? Maybe in your commutation, right? So you will be able to get the look for those problems, try to define those problems, and look for the data and try to implement some small solutions. Don't go for look for the very complicated one. Everything need not to be on the web, everything need not to be on in terms of app or Android app. Okay, but if you can create some use cases of the problem in and around using the some basic algorithm, even then that will work. Even if you will be able to, people will be able to bring efficiency of 10%, 20%, 30% incremental efficiency, that will be great for the end user, right? अगर आपने अभी जो सिचुएशन है उससे अगर 20-30% भी उनकी लाइफ इजी कर दी, उनकी efficiency you have improved, people have improved, it will be great for the user. So that is the use cases, different use cases, selective use cases we have picked, and it is, and you just go from domain to domain, you go from role to role, you go from industry to industry, you will find that the predictive analytics in one way or the another way is using across the domain. Now let's understand about the some terminologies are there. Many of you already know this. Like the most common is, like, for example, machine learning, and there is a difference, a broad difference between programming, right, and machine learning algorithms. So the major difference is that machine learning algorithms build or trained on the input and the output, right? So we provide the data both for the input, which is called as features or independent variable, and output, which are called as your label or target variable, to create the models, to create the machine learning models or AI model or deep learning model. So that is the broad difference between the programming, where you, based upon the input, you write the code, you write the steps, you write the algorithm, and to match the output, right? So here the programmer has the responsibility to match the input and output using his programming skills, where in the machine learning model our responsibility is to provide the required data, clean data, pre-processed data, and the output, and the model will learn, model will predict, model will get tuned or will learn over a period of time. Initially there might be some based upon your data and the complexity of problem and the algorithm you are using, the accuracy may be lower. But as you increase the data or you do the feature engineering, you do the pre-processing, you retrain your model accuracy keep on going up and better and better and better. So the model, the responsibility is to upgrade or learn is on the model, but to provide the quality of input, the right input, and the output is on the modeler. But whereas in programming, the input is there, okay, but the responsibility of matching the input and output is the responsibility of a programmer. So that is the key difference between machine learning and the programming. Then we have gone through the in the machine learning, there is Supervised machine learning. So supervised machine learning is a subcategory of machine learning which has the label data set. So what is the exact meaning of label? So label is your output. So like what you want to predict, right? What is the, which is the variable is of your interest, what you want to forecast, right, or estimate, that is called as a label. So other names or synonyms for labels are output, dependent variable, target. So that is your small y, or the label is there. So if that is available, and along with the features or input variables, independent variables or attribute, right? So if we try to predict or estimate my output as a some function, okay, as a some function of the input, then we are dealing with the supervised machine learning and supervised machine learning algorithm. So here the understanding or the availability of output and the availability of input is there. Now there is called as a unsupervised machine learning. So unsupervised learning is a domain where we don't have the label or output. We have the features or unlabeled data is there, right? And the what is the prime objective? The prime objective is to discover the pattern, right? It's not about finding out the or predict something specific. It is to discover the pattern. Are there some association are there similarity, are there any dissimilarity in the data sets or the pupil or whatever the data is of? So the few of the techniques are like clustering, recommendation, association, your principal component analysis, and so on. And it is especially unsupervised machine learning is important when there is a either no label data is there, or no even your domain expert is there to label them. So then the unsupervised machine learning techniques are used, especially your clustering and the association problems. Then there is called in predictive analytics is called as a unsupervised or semi-supervised machine learning. So how this semi-supervised machine learning works? So semi means partial. So we have the label data, yes, but it is partially available, maybe 10%, 20%, but not all of the. So one way you can say just ignore the information for which our output is not available. But if we try to do that, then in that case we are going to lose the major portion of our historical or previous data. So we deal with this with the semi supervised machine learning algorithm. So that is the another technique within the predictive analytics, where you have a mix of labeling and mix of unlabeled data. All right, then we use the semi supervised machine learning. So these are the three broad, and there is another is called as reinforcement learning. So those is also used for predictive analytics. Any questions so far in terms of understanding the use cases? So reinforcement learning is where we there is a we learn from the environment. It's from the environment we learn. That is the domain of reinforcement learning. Semi supervised learning technique, like for example, you would like to launch a product or developed a new product. At that time the information available is very limited, or not available. Okay, so in that case we use the techniques from the semi supervised or unsupervised. So generally it is said that most of your supervised problem starts from the unsupervised domain, then it moves to the supervised. So initially, so electricity generation is about the predicting the next day demand for electricity. So if we will be able to predict with some accuracy the demand for next day electricity, because you know that the electricity cannot be stored, right? So either you can use it or it will be get wasted, right? If we produce less, it means that there is a loss of productive hours. If we produce more, means a loss of resources. So electricity forecast or the matching the demand and supply is very crucial for this industry. So here we use to predict the next 24 hours of electricity for a period of 15 minutes. Varad, we will see today in our hands-on example that how to make sure that or how what are the how we will find out whether our prediction is correct or not. Okay, so we train our model and then we test our model. So with the test sample we will be able to find out that how accurate our model is. Manoj, like for example, predictive analytics in medical has nowadays have been, first of all, it is the need of the hour in the healthcare. So like in healthcare, you know that because of geography, it is healthcare is something which is a professionals driven, right? Only if you have a professional degree, if you are a doctor, MBBS, then only, and it is a very high skilled job is there. Very high skilled job is there for in terms of, and also the reach is a problem with growing population, aging population, new diseases, and so on. There is always a challenge. So if we use the machine learning and AI, we will be able to deliver or give access to the people to the healthcare at the remote location. Now because in India especially, the internet and the mobile penetration is large, so you can say that if we will be able to deliver or create some interface where the people can give their details or give their reports in terms of some like for example in rural, the problem is like there the availability of expert opinion, right? People come to AIMS with their reports, right? Local reports. So there are labs who can generate the report where you can do your blood test, you can do the X-ray, you can do the MRI, but you always need some expert to look at them and refer you or give you suggestions and predict the disease stage of the disease and so on. If so these experts are always are rare resources are there. Okay, a very costly resources not available everywhere in all cities in remote location. So with the use of ML and AI, these will we provide the previous data, previous report, and how this, and try to make the machine learn, the algorithms learn, and able to give the rightly and timely medical services to the at remote location at a much faster rate and at a much lower cost also. So that is why the predictive analytics in healthcare, you are going to see a major growth, and also same will be true for your agriculture also. So these are the two where we are going to see a major growth in predictive analytics. So the first, Akash, will start from the problem statement. So it depend upon your problem, that what is the technique is good for and the data available in hand. So you can't say that this is the right approach for this. So it depend upon to what you want, what type of resources you have. Let's say for example you have all the resources, all the time in your hand, you can go for the best. But most of the time instead of going to the best, we go for optimal. You know the difference between the best and the optimal. बेस्ट इज समथिंग कि उससे बेहतर नहीं हो सकता, ऑप्टिमल मतलब कि इस सिचुएशन में इससे बेहतर नहीं हो सकता. आर यू गेटिंग द डिफरेंस? The best is that nothing is better than this. Optimal means that in particular boundary conditions and in this situation, this is the best result. So depending upon what is your use case, what is your resources in hand, what type of data you have to choose and pick the algorithm. Is it okay? Say for example, you have only a small data set. So despite you know that the ANN models will do better, but you will not able to use them. Why? Because you have a very small data set. Are you getting? So it depend upon lot depend upon the what type of problem and the resources and the data set you have. So in this class or in this bootcamp, we will do two problems. Okay, so we will see some real challenges in solving the problem, and may get a few insights or few new ways to look at the same problem, right, from a different perspective. So the one problem we will do for the prediction of the mileage of the vehicle. So this data set is there. Yes, so Divya, so that is true for because of human also, and that is true for machines also. So there is always a chance of unintention unintention errors or mistakes. Kushal, whichever language you know is good. Okay, so it's not about either and or. So all languages are good. It is depending upon what where you comfortable, right, and where what you want to deliver. R is more statistically oriented language, right? Right. It has great packages, great support, and for if your inclination is to policy making, statistical packages, and so on. Python is more of deep learning and engineering driven, or when you want to deploy in industry, you look for the production of your algorithms or your code, then Python is the case, right? But research orientation, R is has a much strong library and better algorithms. But most of the time, the people use R also and Python, or mix of both also, because few libraries are good in R and other is this in Python. Python is good at the production, good for cloud computing, good in deployment. Okay, so let's understand. Let me share. So you people are asking for the data set. So let me first give you people the data set. Right? Right. So I urge the people that do the practice or understand or hands-on within the bootcamp. Pawan, mileage per gallon, not gas. Okay. So this data set is an old data set, right? Why we have chosen it? Because of one, it is very close to the reality in terms of like average mileage prediction, fuel consumption prediction. It's about automobile, right? And the variables used are very common, like number of cylinder, displacement, horsepower, the weight of the vehicle, make of the vehicle, and so on, right? So it's easy to understand the, and it's not very complex data set too. But we will see that few techniques like here, like if you have a problem in real world like this, that how to solve them. Don't, it's not always that we run the algorithms. We also have to do some sort of EDA. We have to look for the pattern and then decide which algorithm to use and which algorithm not to use. Okay. So this data set has attributes or feature, or your independent variable, like number of cylinder in a vehicle. Like for example, car has 3 cylinder, 4 cylinder, 6 cylinder. Displacement of total displacement in the engine. What is the horsepower of a vehicle? What is the weight, total weight? Because your mileage depend upon the weight. So more the weight, lesser will be the average of the vehicle. Similarly, more the displacement, less will be the average. More the power, less the average. So bigger the vehicle, less will be the average is there. Okay. So then we have make of the vehicle, origin of the vehicle, and the name of the company or the model. So these are available. Now the first thing is to import the library. So we first, what we will do, we will import the libraries. So we say that we import the first four. One are, say, pandas, numpy, matplotlib, and cbon. So these libraries we import. So we import in either this Jupyter notebook or Colab, right? So we first import the library, then using the URL, we import the data set. So the next step is to import the data set. After importing the data set, we have to look for the first few rows. So the function, the command we use is the df.head, right? So we look for the first, then this is the df.head is there. So you'll see that it has the first 5 lines. This is the mileage per gallon, which is 18, 15, 18, and so on. Number of cylinders, displacement, total displacement, the volume of the engine, horsepower, what is the horsepower of the engine, the power of the engine, overall weight of the vehicle, acceleration, right, 12 second from 0 to 60. So how much second is required, model of the year, origin of the country, and the name of the vehicle, or the make of the vehicle is there, right? If you see, so there is a command called as a df dot. So there is a command called as a df dot number of unique. Okay, so if you look at and run that, we will find out that especially like for example categorical variables, don't look for the continuous variable, right? Because continuous variable have many unique values. So we are our why we have run this function a df on a number of unique values on to find out the categorical variables, how many category or class are there. So if the cylinder are 5 categories are there, right? Similarly, for model of year, there are 13 different years are there. Origin of country, there are 3 different origin of countries are there. And the name and the model, there are 305 names are there. So that is the categorical variable we can see using how many categories are there using the simple function as our data frame name dot and unique we will be able to find. Then we need to do some sort of pre-processing, or we want to look and watch our data. So we will see like look for the first and the most important pre-processing part is to look for the missing value. If your data set has any missing value, so that is the we have to look at. So the function df.info will be give you two major information other than the number of rows and the number and the name of the column. So will we find out from this range index that how many rows are there. So there are 398 rows with index 0 to 397. Okay, we have 9 columns are there with index 0 to 8. Then the column names are given here, mpg, cylinder, displacement are there. Okay, now we are expecting that the data should have a 398 values in each column. So non-null, so there are 398 values are there except horsepower. So have you seen that except horsepower, everywhere we got the 398 non-null values. 398 non-null values. This means what? This means that horsepower has a missing value. This means that the horsepower has a missing value, right? So our data set has a missing value, right? Other than that, we have to see the data type. So we are expecting our mileage to be a float. Yes, it is a float because mileage is a continuous variable. So it has to be a float or an integer. So it is a float. Great. We want our number of cylinder to be an integer because they can't be. So there is nothing called as a 2.5 number of cylinder in a car. So they can be either 2, 3, 4, 5, 6 and so on, right? It can't be in fraction. So yes, it is an integer. Displacement, again, displacement is a volume of the cylinder. So volume can be any, it can be a continuous variable, so it is a float. Horsepower is again a float because it is in decimal. A weight, which is again a continuous variable, here it is an integer. Okay, acceleration, it is a float. Great. Model of year is an integer because that is the year. Origin, name of the country, and the name of the vehicle is an object. So we can find out, you can see that here the number of rows, number of columns, name of the column, missing value, and the data type. So now we have seen that there is a need to look for the horsepower, which has a 6 missing values. So what we'll do, because the number, so how we can handle the missing value? How we can handle the missing value? So we can handle the missing value because the number of missing value is very small. It's just 6. So we can ignore or we can remove them. We can drop, right? If there are more, then we have to look for fill it with maybe a mean value, average value, or using some sklearn function or statistical function like your knn importer, etc. So here what we'll do, so we will one thing have to look for the missing value. Great. Now let's see the describe function. So describe function will give us what? It will give us the summary statistics. It will give us the summary statistics. So summary statistics are there, like for example that how whether there are missing values or what is the number of count. Again, horsepower has 392 vis-a-vis others having 398. Okay, a mean value, you will be find that the mean value 23. But let's see about the features. It is coming out to be 5, 193, 104, 2970 average weight, and 1576. So what it signifies? It signifies that our data set has a different scale are there. Different scale are there. So we have to, other than the missing value, we have to look for the removing the scale effect in our data set also. So that is how the describe function will help us. So we need to standardize the data. So two pre-processing requirement has been identified. One, there is a missing value, but only 6. So we will go for the drop. Second, the mean value or the average value coming out from the describe function is different. So means that the our data sets, our columns, our features are on different scale. So we have to make them on the same scale before running the model. So two requirements are there. Then we'll go for the correlation. Now, why we look for the correlation in our this? So we look for, like, we want to predict the mileage. So first we have to see that this mileage, this is our y variable. So we will say that, so this is our y variable, which is a mileage. So we have to look for that if there is a correlation. So this feature, they have a correlation. Okay. So correlation can be found out in two ways. One, using the correlation values, and another using the scatter plot, a visual one. Okay. Scatter plot. So if there is a correlation, that we should use those features instead of we go with for the features which do have a weak or no correlation, right? So let's see, like for example, if we find out that the correlation is like this, something like this, so it seems to be a positive correlation. If it is something like this, it seems to be a negative correlation, right? And if it is spreading like all around, it may have a it may have a weak correlation or the zero correlation are there. Okay, if it is spreading like this. So so this df.core give you the correlation value. So mileage has a, so let's look at the displacement. So it has a 80%, right? Because it is in decimal, it is in percentage, so it is 80%, very high correlation between displacement and the mileage. Then the horsepower, 77%, high correlation, though negative. Okay, weight again 83%, and acceleration has a 42%. So you can see that these continuous variables have the, like, displacement, horsepower, weight has a very high correlation with my label, my which I want to predict, or the mileage. Now if we go to the cylinder and the displacement, now what is the correlation between cylinder and displacement? What is the correlation between the cylinder and displacement? Can anyone tell me? So Varad has just notified, sir, mileage and displacement has a very high correlation, and also the cylinder and the mileage has also a high correlation. Now, very good observation, but what is that signifies? What does it signifies? That y is how much correlated with your displacement, and y is how much is with the cylinder, and how much is cylinder and displacement. Okay, so cylinder and displacement are 95% correlated. 95%, 95% is as good as 95 is as good as 1. Now mileage and displacement are 80 and 77. So we say 80 and 77. Now you tell me, instead of cylinder, if I use both the cylinder and the displacement in my model, what will happen? What will happen if I use both the cylinder and displacement in my model? These two are very highly correlated. Cylinder and displacement are very highly correlated. Say for example, I give you, like, price of petrol and price of diesel. Okay, are they highly correlated? Are they highly correlated, price of petrol and diesel? Yes. Like for example, if I give you the price of petrol, would you able to predict the price of diesel with some accuracy? Yes. Or I will give you the price of diesel. Would you be able to predict the price of petrol? Yes. Why? Because highly correlated. So if two features are highly correlated, we should we should use one of them. So either use cylinder or use displacement, one of them, because they are actually almost a same variable. And if you go, the people who understand the automobile, okay, or understand the engine, they know that the number of cylinder into volume of one cylinder gives you the total displacement. Okay, actually they have the perfect linear relation is there. Okay, so they are highly correlated are there. So have you understood? So in our, so from this there are two observations are there. One, my mileage is highly correlated with displacement, horsepower, weight, and relatively less correlated with the acceleration. Okay, done. But also at the same time, cylinder and this are displacements are almost one. They are 95%. So they are almost one. So we have to use either of one. Either of one. Is it clear? Is it clear? So you should avoid using two highly correlated features in your model to avoid the issue of multicollinearity. There is something called as multicollinearity. So you should avoid that. To avoid that. So one means 100%. Kushal, it is in percentage. Okay. So one is 100. 0.9 means 90%. Is it okay? Now let's move ahead. So we have find out that from our data set, there is a need to look for the missing value. There is a need for the standardization, and there is a need to not select all the features. It's not that कि आपके पास information है, data है तो सब model में use कर लीजिए. No, right? You should not use the variables, the features which are highly correlated. You should use the one. So we go with the displacement. Why? Okay, we go because displacement is a continuous variable and we will use it in our model better. So how to deal with the missing value? Do you want it to fill with some, you want to fill it with some values, or is it okay if I drop the 6 missing rows? So it's okay in this case. So Aditya, the one which is easy to use and the information is easy to available, right? Now, which one I will use? Like for example, so there are both coming from the domain and some technical is there. Like for example, the formula for displacement is equal to number of cylinder into volume of one cylinder, volume of single cylinder. Okay. Now we have both the information we have the information about the displacement also, we have the information upon number of cylinder also. Now if I use only number of cylinder, I am not using the information which is available in volume of cylinder. Are you getting? Because both are 95, you have the option to use any. But if I am using the displacement, I am somehow is also, this information is not available to me as a feature. What is the volume or the size of single cylinder in the car? This information is not available. But by mere using the displacement, I am able to use this variable also, which is not captured in this data. Is it okay? So this is coming from the domain knowledge, understanding about the automobile, right? So anyone is from the, like for example, mechanical engineering or automobile engineering, they should appreciate that this is the formula for the overall displacement or CC of the engine or the vehicle. Is it okay? That is also mentioned on your RC book. जब आप अपनी आरसी बुक देखेंगे स्कूटर के अंदर तो देयर इज टू व्हीलर देयर इज ओनली अ सिंगल सिलेंडर मोस्टली, so it is same, but in terms of car you will find that total displacement or total cubic centimeter cc of the vehicle is actually cubic volume or the cc of one cylinder into number of cylinder. So one is this. Second is from the perspective of modeling. Displacement is given to me as a continuous variable. I need not to do any further processing on it. But this number of cylinder is given to me as a object or as a category, right? And if you search, or if, like for example, if you search, like, so you will find that there are vehicle with 3 cylinder, 4 cylinder, 5 cylinder, 6, 7, 8, etc., etc. So there are broad categories are there. So that's why we'll use the displacement in this case. Okay. So availability of data, accuracy of data, and the richness of information in the data. So now we will deal with the missing value. So we will do with df.drop na, right? And this will what do if I run. So what we have done in this code or in this cell, in my data frame, I dropped the NA values, means missing values, and I overwrite or saved it as a DF again. Okay, after dropping. So let's say, so I say shift enter. So you will find that now each of the column has 392 values. Wherever there is a missing, that has been dropped or removed. Right? So this is how we deal with the missing value, because the count of missing values in this data set is small. Now, there is another function which is called as a pair plot. So let's develop or create a pair plot or scatter plot of our mileage versus the features. Now, based upon our discussion here, okay, so we are going to end and understanding that on the mileage, say for example, name of the, there are 305 unique names are there, or origin of company for this particular exercise. Okay, or this example, we are not considering make or year of the model, right? Origin of country and the name of the model for this. And we have just seen that the cylinder and displacement are highly correlated. So we are not using the cylinder, so we are using the displacement, horsepower, weight, and acceleration. So these four features we have decided for this exercise to use. Okay, not cylinder we are not using. I have given you the logic. Model, year, the make of the model, the origin of country, and the name of the model. So name of the model, there are 305 categories are there, so it's too big. Model and the origin we are not considering for this example. Now if I create a pair plot or a scatter plot between mileage on my y-axis, mileage on my y-axis, and displacement on x-axis in this scatter plot, horsepower here, weight here, and acceleration here, and this is the distribution of the mileage, now what is the observation we have looking at this chart? What type of a relation this have? What type of a relation do we have? Positive correlation? It is a negative correlation. So as x increases, y decreases. So it has a negative correlation, right? For my displacement, for horsepower, and the weight. So as the engine size getting bigger and bigger, your average or mileage getting lesser and lesser. As your vehicle has a large horsepower, getting more and more power, bigger and more engine, so your mileage is less and less. Okay, as your weight of the vehicle increases, your overall average is also decreasing. So there is a negative relation. And in acceleration we are finding there is a weak correlation, seems to be so it's a scatter. Okay, so it's still a 42%, Rutuja. We can't say that it is no correlation, but it is a scattered. So we are doubtful. That's why we are still keeping this feature in our model. We are not sure. Looking at the value of 42% here in the scatter plot is not clear. So we would like to keep in our the model instead of dropping. Now let's create a simple regression visualization between displacement, okay, one of the variable, because we are creating a line, and a mileage. So this is the regression line, simple regression line of y is my mileage which we want to predict, and the displacement over, or the overall size of the engine, the size of the engine, or the displacement, or cubic capacity, or the volume. These are the different name of displacement versus the mileage. So it seems to be like a line. Okay, so there is a observation that here the relation seems to be downward. The correlation seems to be negative. But is the relation a linear? Is the relation linear? looking at this, so or it seems to be like a C or a curve. Are you getting? So looking at the scatter plot, it seems to us that there is a negative correlation. Okay, so we are not. So it's a way positive, negative, but the correlation is high in either positive or negative. But also we are seeing that it's not a linear. It seems to be like a curvature. What it says, when initially you increase the horsepower of the car, your mileage drop at a faster rate, but over a certain point, but as the your mileage, you are increasing your horsepower, the decrease in the mileage is getting lower and lower, incremental decrease is getting lower and lower. So it seems to be not a linear relation. Okay, but in this exercise and this, for example, we try to first create a linear, and then we will go with for the polynomial regression, and then compare the result. Is it okay? So first we will go for the linear regression, and then we will try to fit the polynomial regression, and then see the what is the increase in the accuracy with these four variables as a features or independent variable. Now let's define our target variable and feature. So that is the next step in our machine learning algorithm. It is a supervised. So we say, let's say, what is our total number of columns, or name of the column, or the label of the columns, using the function df.columns. Then we pick the mileage and define it as a y. So we assign y as our mileage. Okay, then we'll see the shape. So it has 392 observations are there in our y, right? So 392 observations are there. Okay, then we define the column name as displacement, horsepower, weight, and acceleration. Okay, weight and acceleration as our feature or independent variable, right? And what is the shape? We have 392 observations. Yes. Also, we have four columns as displacement, horsepower, weight, and acceleration. So this is how we will be able to segregate or separate or define our label, target variable, and our features or independent variable. Now we have seen that the our mean average of different columns are quite different, right? They are not very close to each other. Okay, so what we need to do before actually running the model, the first thing we have done, we have removed the missing value. Second, based upon the correlation, we have not considered the number of cylinders in the same problem, we have chosen the displacement. Okay, the third, based upon that the mean are on the different, right, scale is a different, we need to do the scaling or standardization of the data. So we are going to use the library from sklearn from the pre-processing module, which is standard scaler. So we run the standard scaler, then we activate it. Okay, initialize it, standard scaler, and then we will fit and transform in a single line standard scaler on X, and rewrite our features, right? Before that, our features are having the values, okay, like this. So these are our features which we have extracted from the complete data frame. We have four features: displacement, horsepower, weight, and acceleration, right? But after doing the scaling, okay, so after doing the scaling, my features are not 304, and so they have been now in a with mean 0 and standard deviation 1. So they have been rescaled, all have been rescaled. So if we say, we will see now, after doing the standardization, the mean of all of my features have been 0. They are 10 to the power minus 16, minus 17. All the columns or the features have the standard deviation equal to 1. So we have converted. Before we doing the standardization, the mean and standard deviations of our these are different. It is 23.514, 5.193, 104, 2970, so and so on. Okay. After doing this, the pre-processing part, we need to train the formula for Z score. Okay. Z score is X minus mu upon sigma. Now, say for example, these are the X. So I considered like let the X will be 10, 12, 20, 8, 7, 14. Okay. Now these numbers are there. So without calculating, I am assuming that the mean is say 15. Okay. Mean is 15. Right. Now when X minus 15, standard deviation is there. So the value coming out to be negative. Are you getting? Wherever it is more than that, the value coming out to be positive. So negative means that those values are negative where it is lesser than the average. So say for example, average height of the people. Some people are smaller than the average height. Some people are taller than the average height. The people who are smaller than the average height will have a negative standard score. The people who have a more than the average height, they have a positive standard score. Is it okay, Himani? What is the meaning of negative and positive? Right. The shape of 398 for Y means that it is has a 398 rows and no column. That is the meaning of shape. So three. Okay. Now let's move ahead. So we have now to do the train test split of our data set. So we have to, this is the function from the model underscore selection, train test split. So this function we require train test split. After that, we have to, using the code, we will be getting a 4 data set, x underscore train, x underscore test, y underscore train, y underscore test equal to, then we will use the train test split function and we will split the x and y. Now this x is our, which x? This x is our standardized x, right? Because we have overwritten with the standard function, then y, and we are splitting into 70-30. So 70% is our train size and 30% is our test size. So let's see the shape of our data set. So it has, in our train sample there are 274 rows or observations are there. In our test sample there are 118 are there. Total are 392. So that is how our data set has been splitted. Now this is a, our mileage is a continuous variable. So we need to use the regression. So there are multiple regression algorithms are there, like your ordinary least square method. There are other methods like your KNN, your decision tree, random forest, SVM. So there are many algorithms are there. So the purpose here is to find out like how the data, and you have to understand your domain understanding, the difference between the cylinder displacement. Are they same? Are they different? Because that information is coming not from your Python programming, but your understanding of a domain. So the purpose of this small exercise is to make you people aware that while tackling any ML AI problem, you should think beyond coding also. Don't take these problems as a coding challenge. Don't take these problems as a as a as a problem to for Python programming. Okay. So because this is we have to, you have to do based upon your problem statement for your end user. So you have to consider the domain knowledge. You have to also consider the domain constraints while solving this problem. Now let's move ahead. So we will be using a linear regression, right? So this linear regression machine learning algorithm is from module linear underscore model of sklearn library. So we use this. So then we initialize this function and giving it a name as LR. So LR is our now a linear regression model, right? Now we fit this model or we train this model on our training data set. So we got four data sets from while splitting this our data set original X and Y. So we got X train and X test. Similarly, we got Y train and Y test. For our learning purpose, we are using the train of X train and Y train, right? So we have done it. Then we see what is our intercept, right? Okay, because if we are fitting a line, if we are fitting a line, so this line will have its intercept, right? This line has a slope, because this is how any line is defined. This is how any line is defined. Okay, so if I have to go with a function, say for example here the line is like this, so it has a some slope. This is the intercept. Okay, where x is equal to 0, what is the value of y, and it has some slope. Okay, this is the slope. So if we know the slope and intercept, then we can write the equation of our line, or we can write the equation of our linear regression. Okay, so intercept is 23.48. What does it mean? It means that the value here is 23.48. Now then we have, these are our coefficients are there, right? So we run this. So our intercept is 23.4. Then our 1.05 is our displacement. Okay, and minus, then minus 1.68 is of our horsepower. Then 4.10 is for weight of the vehicle, right? Minus 0.15 for the acceleration. Is it okay? Plus error. So this is the equation of our regression equation, or regression equation we got in our this data set, right? Now let's use this model for the prediction. Okay, so we have created this line. So what is the meaning of prediction? So why is like that? Now we got the coefficient, the intercept, the slope. Now in from our X test sample, right, we will keep the values and calculate the each value. So we'll say, right, we predicted using X test, Y predict, and these are the predicted values of our mileage for our test sample, which is 30%, right? Now we are going to compare this predicted with the actual. The actual of this data set is stored in the X Y underscore test. So we will compare y underscore test with the y underscore predicted. So we, in this case, the accuracy we are going to find using the mean absolute error and mean absolute percentage error. So what is the mean absolute error? The mean absolute error is 3.32. Okay, this is the mileage per gallon, miles per gallon. So we are able to predict the mileage of the vehicle in our test sample with plus 3.3 to miles per gallon. And what is the absolute percentage? It is around 14%. So our model is around 14% is the absolute percentage error. And what is the overall fitment of our model? Okay, so it is able to explain the 70%. 0.70 means 70%. So these are the three critical, I will say, performance or the matrices are there. So our model is accuracy is 3.32 in terms of absolute error, is around 14.7 in terms of percentage, absolute percentage error, and our model is able to explain the 70% of variance in the model, or R square. So this is the approach we have done. So we have started with the data set. So let me rephrase. So we started with the data set, we have imported it. Okay, then we have seen that there are the different columns, values are there. We have seen that there is a missing value, so we need to treat them for the missing value. We have seen that the scales are different, so we have to remove the scale effect. Then we have seen the correlation. Then we find out that the correlation between the cylinder and the displacement is high, so we should use either of one. Okay, So then we have to remove the missing values, right? Then we visualize. In the visualization, we find that there is a negative correlation, which is evident from the negative sign of the coefficient also. So what we are able to see in the scatter plot, so if it is a negative, then also the value of coefficient is also negative. So in both, in all displacement, horsepower and weight, we got the negative, right? We got the negative. So this is how we want to fit a simple linear regression between the mileage and the displacement and show. Okay, so this is how it looks like. This is your regression line fitted on the for mileage, fitted on displacement, right? Then we have defined our y and x. Y is yes, our mileage, we want to predict the mileage. Then we have chosen the 4 variables, displacement, horsepower, weight and acceleration to predict this. Okay, so this is the values before the standardization. In their original unit, like displacement is 307, horsepower 130, and weight is 3504, and acceleration is 12. Okay, then after scaling using the standard scaler, we have again seen that now the units have been changed, or they are on the same scale. And what is the scale? That is called as a Z scale. Now the mean of all the columns is 0, and the standard deviation of all the column is 1. So the scale effect has been removed. Then after that, we have done the train test split of our data into 4 subsample of train and test for each x and y. Then these are the shapes: 274 observations in our train sample and 118 in our test sample. Then we have used the linear regression to train our model or fit our model. Then after that, we have found out what is the intercept, what is the coefficients, means slope, and then make a equation. So our mileage is equal to 23.4 minus, right? There is a negative correlation we have seen in the scatter plot. So minus 104 times the displacement, minus 1.68 times the horsepower, minus 4.10 times of the weight, and minus 0.115 times the acceleration plus error. So this is our regression equation, right? So what does this means? 1.05, that keeping all other constant, a unit change in displacement lead to the decrease in mileage by 1.05, so miles per gallon. So then we have predicted using our this model, and we got the predicted values. Then we compare our predicted values with the actual y test and find out that the mean absolute error is 3.32, the mean absolute percentage error is 14.7, and r square, the overall explainability of our model, is around 70. So r square gives you the whatever is the overall explainability of your model, how much variance is able to explain in our model. Now let's see that we find out that we are doubtful that our model may not have a linear relation. Okay, so it may not have a linear relation. It may have a relation like this, curvilinear. So if we want to this, we can say it is a square relation or of a degree 2. Degree 2. So let's try to model like this with degree 2. Okay, so we say for this we have to change, or we have to find out the, so this is applicable for features. Okay, so we have to find out the power or degree 2 value of our each feature. So we'll say so the polynomial feature function is available in your pre-processing. We run it, and then we have said that it has a degree 2. So we define the polynomial features with degree 2, right? Then we fit and transform. The function is same. So we have fit and transform on x train data and on the x test data, right? Separately. So we have converted them. Then we, using the same degree 2 or polynomial data, we fit the model. Then these are the intercept and these are the coefficients are there. Then we predicted, and let's see what is the mean absolute error or explanation. So you find that the mean absolute error in previous case is around 3.2. Now it is 2.7. Mean absolute percentage error is around 14. There is increase or betterment of by 2%. and the explainability is also almost increased by 4.6 or 5%. So, so using the appropriate model for regression, right, we can do this. Now, some people are asking why we have used the degree 2. Say, for example, if your model has a curve like this, so there are one curve. So degree is number of turns plus 1. Okay. So there is one turn, so it's degree 2. If there is a chart, it's a graph like this, how many times it is turning? 2 times. So degree is 2 plus 1 is equal to 3, and so on. So that is how you can, using your visual, you can find out the degree. So we have done this problem or on a small data set, but very intuitive in terms of it is forcing you to visualize the data set and then take the decision, right? If you take the accurate decision, you will be able to increase the accuracy by 5%. And 5% is not a small amount, right? So from 70 to, you are able to increase it to by 74.6 or 75%, almost 75%, just by choosing the right polynomial function or applying the right polynomial linear regression. So we have not changed, gone to the other algorithm, like instead of linear regression, you say straightforward jump to the random forest. You straightforward jump to the other algorithms. No. So can I improve? Can I do keep on using the same algorithm, but with my feature engineering, by selection of appropriate input variables, and so on. So this is the crux, and this is what is actually required and desired in your real world. So you should not always go for the complex model. Okay, first try to, because first try to use the simple model and also work around with your data and data pre-processing skills, your domain knowledge, to get the better accuracy. Now after this, we will move to the classification, right? So we will move to the classification problem, right, in a supervised machine learning. And this time we have chosen the handwritten digit classification to solve the problem. So like for example, you have an image, black and white image of the data set, and how we can classify them, right? So Divya, I will recap in the end. Okay, so how we can do the classification. So it is a digit classification are there, and there is a 0 to 9 digits are there, handwritten digits. So if we are able to identify the digits, then we will be able to identify any number, right? Because any mathematical number is made up of these only 10 digits, 0 to 9, and these are black and white digits of 8 by 8 pixel, right? So these are very standard 8 by 8 pixel. So that is the pixel size of the digit. 8 by 8 black and white digits are there. Okay, from 0 to 9. 0 to 9 digits. So the data set is there in the sklearn library. We are going to use it and see what is required in terms of image, right, to solve the problem or the classification problem. So we are going to use here the another technique, very useful and the famous from the ensemble, which is called as a random forest classifier. So how does the random forest classifier works? It is an ensemble. Ensemble means it uses by default, it run 100 trees. Okay, a decision tree. Decision tree is another machine learning algorithm. So it run the 100 decision trees, and based upon the majority voting, it predict the or give the final class, right? So it's like a way the mutual fund works. So it is a bagging technique, very famous bagging technique. So it runs 100 different decision trees as a model, and then based upon the majority classification, it will assign the final class to that particular uh, value. Say for example, if I have to explain, like this is a random forest, it is running 100 decision tree, 1 2 till say 100. Now you have given the digit as 8 to this random. So now all these 100 decision trees are predicting for 8. Now this decision tree has given it as 8. This has given it as a 4 because it is written like this. Someone has written like this. Okay, so this has given it as a 4, this has given it as a 8. So based upon the majority voting, now in this case the majority voting is for 8, the final prediction is 8. Is it okay? So in the ensemble technique, random forest does not work based upon the single model. So by default it run the 100 decision trees, and whatever is the majority classification or outcome is there, it will assign to that outcome that particular value. Okay, so this is the basic logic uh, of uh, of random forest. Now, first of all, the images have their own, I will say, requirement and the challenges. So first of all, to run this example, we don't require any CSV file because this data set is there available in our sklearn library. So we are going to use that. Okay, so first we will import the different uh, libraries. We import pandas, numpy, and matplotlib in this case. Now, to get the data, there is a module called data sets. So from here, we will import the load underscore digits. So the name of this data set or handwritten digit data set is a digits. Okay, so we load the digits, and then we have assigned it a name as df. Now df is equal to my digit data set. So before I move on, let me give you a quick view of this digit data set. Okay, so don't worry about this code. Okay, so this is how it looks like. So it is a black and white pixel, 8 by 8 pixel. So because it is a 8 by 8 pixel, so the visibility is like this only, right? So but you people can be able to find out whether it is a 0, it is a 1, 2, or 3. Is it so? It is a 8 by 8 black and white image of digits from 0 to 9, and we can make out that whether it is a 0 or a 1 or a 2 or a 3. Now the our issue or our problem is to classify, right, or accurately classify the each of the digits and predict these digits. So that is the requirement. So the same you can extend to your healthcare, medical, like these are the x-rays. So we have to predict that whether the x-rays are for that particular disease, or this report is for that particular disease. Okay, or this picture is for that particular pest in agriculture. So the image classifications is nowadays have a tremendous use cases are there. So and this is the very basic, or I will say very native example of the image classification. So before, what is the, before we use the images, okay, now you tell me what is the shape of image. If I have to store the image, what is the shape of the image? So images are stored as a pixel. So a black and white image is stored as a 2 by 2 matrix. Okay, or I will say in a matrix. So here it is a 8 by 8 because it has a 8 pixel. So it has 8 pixels here and 8 pixels here. So it is stored in a 8 by 8 matrix. Okay, two dimension 8 by 8 matrix, right? When it, instead of black and white, if it is a colored, so it has a another three third dimension also, which is storing the color, or it is basically storing the RGB, red, green, blue value of each pixel in a 3 dimension to give you the image. Now in image classification, there is a requirement. The requirement is that we have a initial, say 2 dimension 8 by 8 pixel black and white image with us. We have to convert into a flatten. This is called as a flatten. What is the meaning of flatten? That if this is 8 by 8 means what, in each row how many data points are there? In each row 8. And how many rows are there? 0, 1, 2, up to 7. So how many rows are there? 8. So each row has a 8. So overall, how many data points we have? 8 into 8 means 64. If I flatten it, it become a single row but with 64 data points. Is it okay? What is the meaning of flatten? That instead of having a two dimension, we are converting into a single dimension. So 8 by 8 image when flattened become a one. Okay, so let's see what is the image shape. So there are 1797 images are there. So what is of 8 by 8 pixel? So that's why it is this is there. So we have 1797 images of handwritten digits from 0 to 9 of each of a 8 by 8 pixel. So what say, for example, for first image, this is looks like. So first image has the 8 by 8. So you see that there are 8 values are there in each row. 0, 1, 2, 3, 4, 5, 6, 7. 8 values are there. Similarly, the columns are also 8. 1, 2, 3, 4, 5, 6, 7, 8. Total 64 values are there. Is it okay? So this is how the image 0. Even if any image you pick, image will be look like this, right? Okay. This image we have shown you above. This is the 0 image we have shown. Okay. Now that is the, and what is the shape of this image? The shape of single image is 8 by 8. 8 by 8 pixel. There are 1797 image. Each image has a shape of 8 by 8 pixel. Okay. Now we need to reshape them, flatten them. So we are flattening them with, we say that the number of rows to be this with one column. So let's say, so this is how our single image look like a array, and the shape become 64, right? So now there are 64 values are there in my each image, and the shape become once. So now complete my data set become 1797 rows and 64 column. Is it okay? Now my complete data set, instead of 1797 image with 8 by 8 pixel, become 1797 image, and each image is of flatten and become a 64. Is it clear? So we need to flatten our image actually before processing it. Even if it is a 3 dimension in terms of RGB, we have to flatten before actually running the algorithm. We need to flatten. Running an algorithm, we need to flatten the image, right? Now, do you think that in the image there is an issue of scaling? We have seen in the last example there is a need for standardization. Do you think that in the image there is a need for scaling the image? There is a need for scaling. Like for example, if this is an image of 8 by 8 pixel, do you think that there is a need for scaling? There is a need. Some are 0, 15, 13, 12, 18 values. There is a need. Yes, there is a need for scaling. So let's see that what is the minimum and the maximum value in my image. So here the minimum and maximum value is 16. Sometime it is 256 and so on, are 16. So we will divide our image pixels by 16 so that our minimum value remain 0 and 1. Now if I instead of I will say values between see, now the values are standardized, and these are between 0 and 1. So we have standardized our standardize our image also, right? So we need to standardize whether you are using any machine learning algorithm or you are using a ANN also, right? So we need to do the scaling of our standardization of image. After that, we need to do the train test split, the same as we have done. Uh, so we do the train sample, same the way we have done in previous example, same, no difference. Split, no difference, and this is how our looks like. So in total, we have 1797 images are there, right? So in my train sample, there are 1257 and 540 in my test. Clear? So this is what we have done. So we have total images, 70% goes to my training and 540 goes to my testing. So the same, the train test split, there is no difference. Only difference is when we have to flatten our images uh, before we actually do the train test split. Then in this, because this is a classification is there, so and the images are there, so we are going to use the random forest classifier in this case. So random forest classifier is a module from the sklearn library and ensemble module. That this random forest classifier function is from the ensemble module is there. So we run this, okay, then we initiate it with and given it the name of rf. Then the logic remain the same. We fit on the train data. So we have a train sample as X train and Y train. We done this, okay, random forest. Then we use the fitted model or trained model, random forest classifier, to predict the values. So this is the predicted values, and you see that these are the predicted values are there. So this the first digit is predicted as 4, 5, 6, 8, 0. These the digits are from 0 to 9. Okay. So now we got the prediction using our random forest classifier also. The steps are easy. I will recap in the end also. So we have predicted our 30% of sample. Now let's go for the model accuracy. So for the model accuracy in the classification, as you know, we go for the confusion matrix and the overall accuracy using the classification report. So this is the overall confusion matrix. What does it say? The first row is for the 0. So there are 49 zeros are there, 48 are predicted correctly. Only one has been predicted as 0, 1, 2, 3, 4. Only 1 0 is been predicted as 4. Similarly, 1 has been predicted 58, all 1 has been predicted correctly, and this is your diagonal is giving you the correct incidence. Off diagonals are giving you the wrong predictions. So this is all about confusion matrix. Then we'll want to see the confusion report, and we'll see that the overall accuracy of our model is 98%. 98%, which is very high, very good. Overall accuracy is 98%. So even if you are taking up an example of data, your prediction of your fraud, your prediction of diseases or images, right? Other than the pre-processing part, much of the coding and the algorithms are same. So let me recap this example of our handwritten digit prediction. We imported the initial libraries as pandas, numpy, and matplotlib. We have used the inbuilt dataset, handwritten 8 by 8 black and white, handwritten digit dataset, and this is the digits of 0, 1, 2, 3 on 8 to 8 by 8 pixel. Then we first thing we do, we flatten our image from 8 by 8 to 64. This is, I have shown you that the initial shape is there are 1797 images are there of 8 by 8 pixel. This is how a single image looks like. It is a 8 by 8 array, and how you see that the values from 0 to 16 are filled. Okay, and you can make out that in center it is values are less, in around the values are very high, then in also there is less. It seems to me like as a 0. It seems to me like a 0. Say for example, if I say 9, okay, so it's some other digits are there. Okay, so it looks like this. Then we find the shape of single image is 8 by 8, but overall data is 1797 by 8 by 8, right? But single image is 8 by 8. Okay, then we flatten it, our images. Okay, then we find that our data set now also become 1797 by 64, not 1797 by 8 by 8. The 8 by 8 images has been flattened to 64, right? Then we scale our images. Okay, the values are from 0 to 16, so we divide each value by 16. So we are getting a value between 0 to 1. So we converted the range, okay, from 0 to 1, right? So now instead of 0 to 16, my images ranges are between 0 to 1. So that is how we do the scaling of images. Then This how after scaling a single 0 digit looks like. Okay, then we use the train test split data. Our 70% data of 1797 is 1257, which is our trained sample, and 540 is our test sample. Then we use the function random forest classifier, and we fit our model with x underscore train and y underscore train, and then we predicted our values, and these are the predicted values are there with the function dot predict and giving x underscore test. These are our predicted values. Then we compare these predicted values with actual y underscore test. And then we find out this is our confusion matrix. So diagonals are correct predictions. Off diagonals are your errors. So we find that much of our data is on the diagonal itself, right? Great. Then we have seen the classification report. And in the classification report, we have seen that the overall accuracy of the model is 98%, which is very good. And overall, also precision and recall in most of the cases is almost 98, 95. So it is also good. So that is, these are the two examples we have done in our predictive analytics, one with the image and one with the mileage is there. Any question so far? Any question so far? Kriti, number of samples is like, for example, for each digit, what is the, okay, you are talking about flattening. Okay, so let me explain. What is the meaning of? Okay, so my number of samples, so my length of my image. Okay, so what is the my data frame length of my image? What is my length of my data frame? There are 1797 rows. So I can write, I instead of that I can write here that convert my data frame or reshape my data. So simply I can write this function as my data. Sorry, I can simply write it as my data is equal to data frame dot image, okay, dot reshape into how many rows? 1797. So I, because I want the initial values, so because there are 1797 are there, and the columns you decide. Okay, the column you decide, right? Because they are going to be 8 after convert, after flattening there are the 64 columns. So either I will write 64 here, okay, okay, but if you don't want to, I will write the -1 is there, right? So that is how it will work. Dipanshu, it is required to flatten the image, convert into a 2 by 2 array before actually putting into an algorithm, right? So you need to flatten whether you are going to run the artificial neural network or your machine learning algorithm. So we need to convert them into 2 by 2 array. So we can do, Pranoy. So Shreya, the confusion matrix will give you, so confusion matrix will give us that the diagonal, right? Like this diagonals are the correct values. So if I have to go, so this is my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are my actual value. And the predicted values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 0 predicted as 0 are 48. But 1 0 is also predicted as 4. Are you getting? 58 is okay. 56. The 56 twos are predicted as 2, but 1 is predicted, 1 2 is also predicted as 1. It is okay. This is okay, but one of the 4 is predicted as 7 because it looks similar, 4 and 7. Okay. 5, 60 are predicted okay, but one of the 5 is predicted as 8. Are you getting? 58, 6 are okay, but okay. 56, this is okay, but one of the 7 is predicted as 9. Are you getting? But in case of 48, you see that 8 is also predicted as 6, 8 is also predicted as 2, 8 is also predicted as 1. Right? So most error you are finding in 8. Then 9, 49. So 9 is also predicted as 7, also predicted as 5, also predicted as 3. Okay? So that is the error. So this is how you can read the confusion matrix. Is it clear? So there is like even a 42% correlation is not a weak correlation. Please do understand. Okay. So let the model decide whether it required or not. Okay. So let the model decide. So weak correlation is somewhere which is around 0, near to 0. 42% is near to 50. It's not a weak. So thanks everyone.